My name is Alex Galt. I'm a math teacher at Edina High School. This lesson is about factoring polynomials to find the zeros. So my objective for you is to be able to find the zeros of a polynomial. And we're actually going to start with a game. In this game, when we look at the x, the number on the top of the x, I want to find two numbers that multiply to make negative 12 and add to make 1. So if I think about negative 12, if I think of numbers that multiply to make negative 12, I've got 1 times 12. Well, if one of those is negative, that would work. I have 2 times 6. And I have 3 times 4. Those are really the only things that multiply to make 12. But if it has to make a negative 12, then I need to make one of the numbers negative, and then it has to add to make 1. So if I make this a negative 3 and a positive 4, notice how I won the game, because negative 3 times 4 is negative 12, and 4 plus negative 3 is 1. So pause the video, try to win the game for these two x's. Try to figure out which numbers multiply to make the top and add to make the bottom. Okay. So what we're going to try to do here is we're going to try to figure out the zeros for this polynomial. In other words, which x values give us a 0 when we plug them into that polynomial. Step 1, and that's always going to be step 1, is going to be factor out the GCF. So make sure you do that first. So if I look at 4, that would be 2 times 2. 18 would be 2 times 9, which is 3 times 3. And 20 would be 5 times 4. And 4 is 2 times 2. So if I look for a GCF, it looks like they all have a 2 in common. So my GCF is going to be 2, and then my biggest exponent, my smallest exponent is 2x squared. So my GCF is 2x squared, and I can take out, if I divide by 2x squared, I'm left with 2x squared plus 9x plus 10. Okay, so then I want to look only at this portion, and when I notice that portion, it's a quadratic, and I'm going to be a little more careful about defining quadratic. A quadratic is something that can be written as ax squared plus bx plus c, where a, b, and c are numbers. So for this quadratic, a is going to be 2, because there's a 2 in front of the x squared. B is going to be 9, and C would be 10. Okay. Now we're going to use the XBox method to factor this, and this is the first time you've seen this, so be patient with yourself and know that we're going to work through it, and we'll do this more than once. On the top of the box, you're going to write A times C x squared. A times C would be 20, so you're going to write 20x squared on the top of the box. On the bottom of the box, you're always going to write bx. So this is a general rule. You're always going to write A times cx squared, and on the bottom of the box, you're always going to write bx. B is 9, so we're just going to write 9x here. Okay. From there, we're going to play that game that we played for the warm-up at the beginning. We're going to look for numbers that multiply to make 20x squared and add to make 9. And it might be helpful to list 1 times 20, 2 times 10, 3 doesn't go into 20, but 4 times 5. And that's all the numbers that multiply to make 20. So if I notice, 4x and 5x also adds to make 9. I want to emphasize that once you've done that, these numbers are the x values that go on our box. Remember when we were factoring using tiles, it was hard to figure out where to put our x's, because we didn't know how to shape our rectangles for the ones in order to make the x's fit. This tool is the tool that helps us decide where to fit the x's. Okay? So the x part is going to help us decide where the x's go and how many x's there should be. The upper left-hand corner of the box is going to be 2x squared because that was just from our quadratic. The lower right-hand corner of the box will be 10. Okay, so the 10 comes from our c value, and we've got ax squared in this corner of the box. Okay. Then what we want to do is we want to write the dimensions of our box. But what we do for writing the dimensions of the box is we look for the GCF for every single column and every single row. So if I look at 2x squared and 4x, I can take a 2x out of both of those. And if I look at 5x and 10, their greatest common factor would be 5. And then in this row, 2 and 5 don't have a GCF or a GCF of 1, but both of those two terms have an x in them. And then 4 and 10 are both even, so I can take a 2 out. Okay. So that whole process was so that I could get the dimensions of my box. Okay. Then the factored form of my quadratic, my polynomial, is going to be 2x squared, which was my original GCF, and then the dimensions of my box. So x plus 2 and 2x plus 5. All of that was a new process to you, and it's a difficult process, so be patient with yourself. Try it, practice. This is not the only time you're going to do this problem, these kinds of problems. The last step, we want to figure out where this thing is equal to 0. Remember, if it's a product of three things, one of them would have had to be 0. So you say 2x squared is equal to 0. You divide by 2, x squared is equal to 0. Oh, well, then x would have to be 0. X plus 2 is equal to 0, so x would have to be negative 2. 2x plus 5 is equal to 0. So move the 5 over, so you have 2x is equal to negative 5. Divide by 2, x is equal to negative 5 halves. Okay, that's the XBox method, and I did it for one problem, and I don't expect you to be a master yet, but I do. Here's a review of the steps of factoring a polynomial. And I'm going to give you permission to put your pencil down and just think for a minute. So the first step that we did was we factored out the greatest common factor. You always want to look for the greatest common factor first because the XBox method doesn't work unless you factor out the greatest common factor first. After that step, you set up your X and a box. Often you'll have to draw that yourself. On today's note sheet, it was drawn for you, but you should be okay with drawing an X and a box yourself. Okay. That looked complicated, but the first thing you do is at the top of your x, you do ax squared times c. At the same time, you could fill in your box. In the upper left-hand corner, your x squared terms are going to go on the upper left, and your 1's go on the lower right. On the bottom of your x, you put your bx term, and then you play the game where you look for two numbers that multiply to make ax squared times c and add to make bx. After you find those two numbers, you put those two numbers in the box in the two empty slots. So those two numbers go in the two empty slots. And then you find the greatest common factor for each row and each column of the box, and you write those factors and the GCF as your answer. This is the problem that we did on paper, but I want you to just watch what we did. So the first thing we factored out the greatest common factor. So we listed out what the multipliers were for each term. We found what they had in common, which I wrote in green here. And then we pulled that greatest common factor out and wrote what was left as a trinomial. That was also a quadratic, which means that it was in the form ax squared plus bx plus c. Then we looked just at that quadratic and we set up our x and our box. And from there, the 2x squared and the 10 go in the box immediately. And also we have 2x squared times 10 in the top of the x, and then 9x at the bottom of the x. Then we look for two numbers that multiply to make 20x squared and add to make 9x. And we found that those two numbers were 4x and 5x. And those two numbers also go in the box. Then we looked at each row and each column of our box and found the greatest common factor for each row and each column. So for 2x squared and 5x, we said that was x. For 4x and 10, we said that was 2. For 2x squared and 4x, we said that was 2x. And for 5x and 10, we said that was 5. So the dimensions of our box are x plus 2 and 2x plus 5. So our final answer would be our greatest common factor, which was 2x squared times x plus 2 times 2x plus 5. And now our polynomial is factored. So that's the process for the XBox method of factoring. It's a lot of steps, but the more you practice it, the better you'll get. Okay, so the first thing we should look for is a GCF, which means that for each of these terms we want to write them in their factored form. So 42 is 7 times 6, or 7 times 3 times 2, and 15 is 3 times 5. And what I notice is that the greatest common factor is going to be 3x. And then I'm going to write what's left, so that'd be 3x squared and 14x, but it's negative, and then 5, and that's negative as well. Okay, so my quadratic is 3x squared minus 14x minus 5, which means a, which is the number in front of x squared, is going to be 3. B, which is the number in front of x, is going to be negative 14. And c is going to be negative 5. So AC x squared, so if I multiply 3 times negative 5, I have negative 15x squared. And then b is going to be negative 14x. Again, it's sometimes helpful to write down the things that multiply to make 15. We've got 1 and 15, 3 and 5, and those are the only options. And if you notice, if you make the 15 negative and the 1x positive, that does add to make a negative 14. Okay. Then when we go to the box, that's a whole nother idea. So we are going to use 3x squared in the upper left-hand corner. And we're going to use negative 5 in the lower right-hand corner. And then the reason we use the x is so that we can decide where the x's go. Doesn't matter where you put them, but one of them will be a negative 15x, and the other one will be a 1x. Okay, then the next idea is we're going to do dimensions. So we want the greatest common factor here. Between 3 and 15, the greatest common factor is 3, and they both have an x. Between 1x and 5, the greatest common factor is 1. And then here, the greatest common factor is going to be x. And the greatest common factor here would be a negative 5. The reason it's negative is because we want to make sure that when we multiply, this gives us a negative 15x, and this gives us a negative 5. So in factored form, remember our greatest common factor was 3x. And then we had, for our dimensions, x minus 5 and 3x plus 1. And all of that was equal to 0. And so when we solve for x, we're going to set each of our factors equal to 0.
Good afternoon,
so we
staff.
have,
This is a reminder.
So we're going to set each of our factors equal to 0. So we have 3x equals 0. So one of our zeros is going to be x equals 0. And we have x minus 5 equals 0. So one of our zeros would be x equals 5. And the last one would be 3x plus 1 equals 0. So we would have x equals negative 1/3. It's a lot of work for one problem, isn't it?